everyone, and welcome back to Educator.com. In this lesson, we're going to talk about friction. Our objectives include defining and identifying frictional forces, explaining the factors that determine the amount of friction between two surfaces, and determining the frictional force and the coefficient of friction between two surfaces. So let's start off by talking about the coefficient of friction. The ratio of the frictional force to the normal force provides the coefficient of friction. Mu is the coefficient of friction. It's unitless, and it's the force of friction divided by the normal force. So friction caused by the interaction of two objects, and this coefficient of friction depends on the nature of the surfaces. So some approximate coefficients of friction for different types of friction. Kinetic friction is objects that are sliding against each other. Static friction is objects that are not sliding against each other. So rubber on dry concrete, for example, has a kinetic coefficient of 0.68 and a static coefficient of 0.9. That means once it's moving, once it's sliding, it has less friction than it does in trying to get it to start sliding. Pretty common to see a static coefficient of friction larger than the kinetic coefficient of friction. Okay, let's take a look at some situations. Are these situations static or kinetic? A sled sliding down a snowy hill. Well, that would be kinetic. We have objects that are sliding. How about a refrigerator at rest that you want to move? Well, that's static. It's not sliding yet. And that's why it takes more force to get something to start sliding to overcome static friction. And once you get it sliding, you're usually dealing with kinetic friction, which is less. Car with tires rolling freely. That's static because it's not sliding. As the tires are going down off the pavement, at any given point, they are static with respect to the pavement. Now, if you happen to skid across the pavement, now you have sliding or kinetic friction. And when you're using that coefficient of friction, you will use either the kinetic, mu k, or the static, mu s coefficient. Let's take the example of a car sliding. A car's performance is tested on various horizontal road surfaces. The brakes are applied, causing the rubber tires of the car to slide along the road without rolling. Without rolling, they're sliding, so right away we're thinking, kinetic. The tires encounter the greatest force of friction to stop the car on, and we have a couple choices here: dry concrete, dry asphalt, wet concrete, or wet asphalt. So I'm going to look for the largest coefficient of friction. That would be right here on dry concrete. That must be our answer. Largest coefficient of friction, largest amount of frictional force.